It's Random News Day. We've got an X-class solar flare,
and an amazing image from JWST.
the incredible effects of a volcanic eruption in space,
A very strong quake on Mars,
cosmic rays,
and cookies.
yeah, cookies. Plus, this week in rocket history, I get to talk about the space shuttle again.
All of this now, right here on the Daily Space. I am your host, Dr. Pamela Gay.
And I'm your host, Eric Mattis.
And we're here to put science in your brain.
If you're like me, you started the day with a glance at the weather and maybe a few choice words for the sun and the summer heat that is bringing many of us far too early in the year. While your standard weather forecast is going to let you know about terrestrial conditions like wind, rain, temperature, and humidity, there is another kind of weather that we're going to need to pay attention to for the next several years, the space weather report. Our sun has an 11-year activity cycle, during which it transforms from a placid ball of spotless plasma to a messy tangle of magnetic fields and sunspots. When those tangled field lines snap, they can release magnificent amounts of energy as flares, including high-speed particles in our direction. These flares can trigger everything from harmlessly beautiful aurora to power grid failures. In between these extremes are communications blackout, during which normal radio and shortwave communications is impossible due to interference from the sun. On May 10th, the day before we recorded this episode, the sun let loose an X1 class flare directly at the Earth. Space weather forecasters at NOAA have predicted high-frequency radio blackouts for most of the Atlantic Ocean and western parts of Europe and North Africa. The region of the solar activity responsible for the spot may release additional flares. Some folks have already seen fantastic aurora, and if you are one of them and you happen to get a good image, please share it with us on Twitter by tagging CosmoQuest X. If you want to keep up to date on the latest space weather forecast, NOAA has you covered at swp.noaa.gov. We'll have that link in our show notes at dailyspace.org.
Our sun is one of the more metal-rich stars we've studied. Its high concentration of heavy elements kind of makes sense. If the cloud of material that formed our sun and solar system hadn't been high in metals, the materials needed to form our world, with its nickel-iron core, we wouldn't have been around. As we work to understand what it takes to form our kind of a solar system, we are looking for stars that capture the history of our galaxy's chemical evolution in their atmospheres. This isn't easy. Our chemically complex sun is more than 98% hydrogen and helium, with just 1.3% of its atoms being heavier elements. We are trying to measure 1 part in thousands when we go looking for complex atoms in chemically boring stars. But we can do it. And sometimes the results are super weird. In a paper accepted for publication in the Astrophysical Journal supplements, researchers led by Ian Roderer detailed the presence of 63 different elements in an otherwise metal-poor star. The majority of the atoms are formed when neutrons bombard the nucleus of atoms and then decay such that the atoms transform into heavier elements. This can happen in both supernovae and during the collision of neutron stars. The ratios of the elements, how much cadmium is formed compared to neodymium, should eventually allow us to say, this star, its elements came from a neutron star merger, and that one over there, well, some kind of supernova. We're still teasing out the details, but this newly studied star has many of the same ratios as our Sun, hinting that both got suites of their material from the same kinds of past events. The atomic ratios in this star don't match what we saw in our one observed neutron star merger. So this further hints that it was supernovae that got this star, and maybe us too, much of the gold we see. And what I find most fascinating about this paper is this one sentence in the discussion. Quote, "We assume that a single R-process event dominated the heavy element enrichment of the gas from which HD 222925 formed." End quote. They're able to look at the star, measure its ingredients, and see how multiple supernovae contributed to the formation of its lighter elements, but only one spectacular event was needed to create its heaviest, those are the R-process, elements. Folks, we're reverse engineering stars, and that is kind of awesome. The more we are able to do this, the closer we will get to being able to say, to get to a planetary system like ours, first, these are the things that must happen. One of the justifications for building the JWST was being able to better understand the origins and evolution of planetary systems. As it slowly comes into focus and shows us what it is capable of, NASA is eager to show off its first pictures, and like any new parent, point out the details the rest of us might not notice. Case in point, this image of gas, dust, and stars in the Large Magellanic Cloud. The glow in the nebula shown here is from my favorite kind of molecule, polycyclic aromatic hydrocarbons. On Earth, these are used to make the artificial scents, and in space, they are just kind of hanging out, glowing softly in the infrared. And in a new image release, NASA compares JWST's capabilities with its predecessor, Spitzer. NASA would like you to know, quote, "JWST will allow us to see the infrared sky with improved clarity, enabling even more discoveries," end quote. Coming up next, we come back down to Earth and talk about how a recent volcanic eruption affected space. Stay tuned.
Back in January, the Hunga volcano erupted and was literally heard around the world. Even Beth, in California, heard the sonic boom that day. Plus, the shockwaves and tsunami waves also had a far reach. And now, in new research published in the journal Geophysical Research Letters, scientists examine how that eruption reached and affected space. Data collected by NASA's Ionospheric Connection Explorer, or ICON, mission and ESA's Swarm satellites was analyzed by satellites, who found that hurricane-speed winds and strange electric currents actually formed in the ionosphere. That's the very topmost charged layer that butts up against the edge of space. The charged particles in that region tend to form east-flowing electric currents, called the equatorial electrojet. After the eruption, the electrojet surged, reaching 5 times its normal power, and flipped directions for a brief time. All of this is due to the extreme winds created from one volcanic explosion that occurred underneath the water. Co-author Joanne Wu notes, quote, "It's very surprising to see the electrojet to be greatly reversed by something that happened on the Earth's surface. This is something we've only previously seen with strong geomagnetic storms, which are a form of weather in space caused by particles and radiation from the sun." The effects of this eruption add another way in which understanding various impacts on space weather is necessary. Changing the flow of electrons in the ionosphere can disrupt GPS and radio signals through that layer, so scientists will continue to study these atmospheric electrical currents.
Speaking of things that go boom, our favorite Martian lander, InSight, recently recorded the largest Mars quake yet, measuring magnitude 5. The quake happened last week on May 4 and tops the previous record, which was magnitude 4.2 and occurred last August. While this magnitude may be considered merely a medium-sized quake here on Earth, and especially for people living in regions that experience quakes regularly, on Mars, it's thought that magnitude 5 is probably near the upper limit of what's possible. The results released this week are preliminary, and InSight science team will continue their analysis to determine the location, potential source, and maybe even something about Mars' interior. After all, that's what they're trying to get insight into, using the reflections of the seismic waves to determine the depth and composition of the crust, mantle, and core of the red planet. Unfortunately, InSight may be reaching the end of its mission as dust continues to accumulate on its solar panels. We mentioned a similar issue with Ingenuity yesterday, and with the Martian winter approaching, the situation will only get worse. The team is doing everything they can to keep the lander up and running, and we'll update you here on Daily Space with InSight status. Our ability to study everything from marsquakes to black holes is contingent on our ability to calibrate and sync our measuring devices. Getting things in sync is strangely one of our greatest challenges. This is due to the limits of relativity and our own technical limitations. If I say sync, different people in the room will hear the word sync at different times because of the speed of sound. If I flash a light, they will get the light at different times too. Ideally, you want systems to have a myriad of things to sync on, and the chance to constantly update timing to stay in sync. And a way to do that is suggested in a new paper in Scientific Reports. Researchers are looking to use atmospheric cosmic ray events to synchronize clocks on and below the surface of our planet. When some forms of cosmic rays strike the atmosphere, they trigger a cascade of readily detectable muons, a kind of particle that can travel through the air, earth, and water, and probably fire too, but we try not to test that in the lab. These events are occurring on a regular basis all over the globe, but are separated in time enough that a suite of detectors under an event will be able to know, I just saw the same event as that detector over there, and use the event to sync the time. This is fairly low cost, completely straightforward, and the authors of this work point out the only barrier to using this technique is getting people to use this technique. I, for one, look forward to a Muon synced future. Next up, Eric returns with This Week in Rocket History. Stay tuned.
Because it's been a couple of weeks since I was allowed to talk about space shuttle missions, This Week in Rocket History is STS-84, part of the Shuttle Mir program. I'll also go into detail on one of the long-duration missions conducted by a NASA astronaut on Mir. Before the space shuttle built the ISS, it docked at the Russian Mir space station. It did this a total of 9 times, and STS-84 was the 6th of these dockings. Shuttle Atlantis launched on May 15, 1997, carrying a 7-member crew up for just under 10 days. The shuttle left 1 crew member on Mir for a long-duration mission and returned with a different long-duration crew member launched on a previous shuttle visit. This was one of a few spaceflights where the launching crew and landing crew of the spacecraft were different. STS-84 was basically just a supply run, exchanging the previously mentioned crew members and bringing up several tons of supplies for the station and its research. Despite this, it set several milestones, including the conclusion of the first continuous year in space for NASA. Part of that year was conducted by the previous long-duration crew member, Shannon Lucid, and the rest by Jerry Lidinger, who had been on the station since January 15, 1997. Lidinger performed 100 experiments during his time on Mir as part of the Mir Expedition 22 crew. Before the shuttle came to get him, Lidinger became the first American astronaut to do a spacewalk from a foreign space station. Naturally, he wore a Russian spacesuit in the EVA, another first for an American astronaut. Lidinger was joined by Station Commander Vasily Tsbiliev for the 5-hour spacewalk. NASA astronauts would do EVAs wearing Russian spacesuits in the early years of the International Space Station as well. Another exciting thing that happened on Mir during Lidinger's time on the station was one of the worst things that can happen on a space station, a fire in one of the modules. Fortunately, no one was hurt. Lidinger also witnessed the impact of the Progress M34 resupply craft during a manual docking attempt gone wrong. Progress M34 had autonomously docked using the dependable but expensive KERS system the previous day. Russian Mission Control wanted to save money and test using the backup manual docking system as the only method. It was not a good test result. These were just a few highlights of the many things that took place on Mir during his mission. Despite all of the problems encountered, Liniger still completed all of the planned science. Liniger was replaced on Mir by British-American astronaut Michael Foale from SDS-84, who would do 35 experiments in his 4 months, 12 days in space, including 2 while the shuttle was still docked. Atlantis was docked from May 16th through 21st, and the crew transferred supplies faster than planned. Among these supplies was a new oxygen generator to replace the one damaged by the fire. The combined shuttle and Mir crews conducted science experiments in the Space Hab module mounted in the shuttle's cargo bay. Most of these experiments were repeats of past ones. It's always worth confirming the results. But 7 of the experiments were new. Elsewhere in the station, the crew took lots of pictures, partially to survey the damage from the fire. The one thing they did not take pictures of was the station from the outside, which previous missions had done. Atlantis undocked the evening of May 21st, but it stayed around the station for some time to test a rendezvous system for the future European ATV, which would be used on the International Space Station. The shuttle would serve the same purpose on SDS-27, testing the rendezvous sensors for SpaceX's Dragon in a package called Dragon Eye. SDS-84 landed back at the Kennedy Space Center on May 24th, 9 days, 23 hours, and 19 minutes after launch. It orbited the Earth 144 times.
One of the long-standing questions in planetary science is how Earth has water and life, and other planets like Venus don't. A key part of the solution may be the electrical fields of both planets. The Venus Express mission found that the electrical field had a strong electrical potential. This means the field could have pulled apart the positively charged water molecules and blasted them into space. The Earth may have a weaker electrical potential in its magnetic field, and scientists think that this is the reason why Earth still has its water. To figure this out, a team will determine how much electrical potential the Earth's magnetic field has. They estimate it to be 25 times weaker than Venus. The measurement is made indirectly. Earth's atmosphere has electrons moving away at a known speed, and any variation in the speed will be caused by the electrical potential.
The last story before we get to the rocket statistics is not one of our usual topics, but it caught my attention while I was looking for stories to write about. The tagline of the story, and what got my attention, is, quote, "Why Science Doesn't Help Sell Chocolate Chip Cookies," and the study itself is pretty interesting. Researchers at The Ohio State University looked at a series of 10 studies covering different product types. Taken together, each of these studies came to the same conclusion. People don't want feel-good things to be sold to them by emphasizing their scientific advantages. However, they do want useful things to emphasize those scientific developments. Aviva Philip Mueller, study co-author, said, quote, "When pleasure and science are paired together, that feels disjointed to consumers, and they aren't interested in those kinds of products. It seems weird to have the coldness of science try to sell you something pleasurable," end quote. The studies were on things as varied as the cookies in the headline, but also smoothies, deodorant, and body wash. The cookie study took 500 students and asked them to rate 3 different cookie slogans. One slogan mentioned its, quote, "luscious chocolatey taste," end quote. The other slogan was, quote, "scientifically developed to have a luscious chocolatey taste." Participants rated the first option over the second by 30%. On the useful product side, another study found that the participants preferred a slogan that emphasized its useful properties developed by science, rather than how it smells or feels on the body. The study also has results beyond marketing, concluding that perceptions about science influence people's reactions to products with a science appeal. Another study co-author, Rebecca Rechek, said, quote, "People need a more realistic view of what scientists are really like and how science is part of our everyday lives, including many of the products we use." The study was published in the Journal of Consumer Research and honestly has made me hungry. And now for some statistics. The number of toilets in space is 7, 4 on the ISS, 1 on Soyuz MS-21, 1 on Crew Dragon Freedom, and 1 on Tianhe. We keep track of orbital launches by launch site, also called spaceport. Here's that breakdown. USA 25, China 14, Russia 4, Kazakhstan 3, New Zealand 3, India 1, Iran 1. From those 51 launches, a total of 854 spacecraft were put into orbit. The random space fact for this week is that when Malaysia's Sheikh Muzaffar Shakor went to the ISS in 2007, it was during the holy month of Ramadan. Concerns about his ability to fast led to Malaysia's National Fatwa Council publishing a list of rules for observant Muslims in space, which included postponing the actual fast until after the return to Earth. This has been The Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining Patreon at patreon.com/CosmoQuestX.